And then this is Chapter 7, Auditing, Testing, and Monitoring, Part 2, where we talk about audit data, collection methods, post-audit activities, and security monitoring. There are different collection methods. Questionnaires can be administered to both managers and users. Interviews are useful for gathering insight into operations from all parties and are often the primary source of information and recommendations. Observation, input used to differentiate between paper procedures and how the job is really done. But one caution about observation is that a user may actually be taking certain kind of shortcuts all the time. And then on the day that they know you're coming to observe them, they follow the procedures exactly as they're prescribed, in which case observation may not be that successful in determining whether the methodology is being followed on a regular basis. Checklists. These ensure that the information gathering process covers all areas. Reviewing documentation. Reviewing configurations involves assessing the change control procedures and the appropriateness of controls, rules, and layout. Reviewing policies. This involves assessing policy relevance, currency, and completeness, and then performing security testing, including vulnerability testing and penetration testing. Areas of security audits and control checks. Access controls, password procedure, how to set them, change them, and reset them to support access control policies. Control checks and identity management, the approval process, who grants approval for access requests. Authentication mechanisms, what mechanisms are used for specific security requirements. Password policy and enforcement. Monitoring, can an organization detect unauthorized access? And remote access systems, are they secured with strong authentication? The purpose of an IT infrastructure audit is to verify that established controls perform as planned. Internal audits examine local security risks and countermeasures. External audits explore attacks from the outside. They answer the questions, how do you know that a proposed security measure is actually effective? And how can you be confident that a policy controls adequately address security objectives? A computer security audit is a logical extension of established policies and procedures that set the protocols and parameters for a system. It verifies that established controls perform as planned and expected outcomes are achieved. Audits verify that proposed mechanisms work as intended and fully support organizational security objectives. An audit actually exercises the system to ensure that the policies and procedures are correct for business needs, that controls support those policies, and that procedures are properly followed and maintained. Audits can scale to large scopes that encompass entire departments comprising various business functions. Audit functions may narrowly address specific aspects of a system or evaluate only particular controls. An audit helps security teams check whether controls are appropriate, correctly installed, and serve their purpose. Audits do not expose potential issues with respect to programming flaws or other exploitable conditions, but should address how to handle them. Audits are necessary to ensure that companies meet with federal regulation, governmental mandates, and industry standards with respect to handling confidential information and sensitive business functions. Audits ensure that laws and regulations require that certain companies must conduct internal and external audits. Companies must be held accountable for safeguarding sensitive information and processes, and an audit ensures those expectations are met. Internal audits concentrate on how internal issues are handled. Internal auditors work directly for the company. They have an inside perspective of what's going on in the company. Internal audits can expose security gaps in the way internal practices or policies are followed. External audits concentrate on how outsiders break into the network. External auditors are contracted by the company with an outside perspective. External audits can expose security gaps in the way regulatory practices are followed. Here we see the infrastructure audit domains, remote access, an auditor will check into your wide area network and how that's handled. the local area network to wide area network, which is your firewalls controlling that, workstations and users, um, your local area network, routers, switches, and hubs. Hopefully, you won't be using any hubs. Um, your internal application services, your intranet, and then, of course, your application web services protected by a firewall here, systems and major applications. An IT security assessment versus an audit. A security assessment examines systems for established security policies and regulatory compliance, whereas a security audit identifies what weaknesses exist despite established security controls. While you can test how administrators and mechanisms respond to a security incident with an audit, the methods used to exploit a vulnerability come from a security assessment. The distinction is simple and the difference is important. An audit will verify that you've taken adequate measures to protect sensitive data. An assessment will validate weaknesses that aren't addressed by policy. So the auditor has done his or her work, and you need to conduct an exit interview, or he will conduct an exit interview with you, and also look into data analysis, and you get an audit report as a result. The auditor performs the exit interview with key personnel to alert them to major issues and recommendations that will come up later in an audit report. Auditors analyze data they collect away from the organization's site. This enables the auditor to review everything learned and to present observations using a standard reporting. Excuse me. Reporting for reporting format. Performing data analysis at a different location from the audited organization helps encourage unbiased analysis. The audit report contains three broad sections: the findings, which are listed by level of compliance with standard benchmark; recommendations, how to fix the risks that are found; timeline for implementation; the level of risk; and management response. The auditor gives the management opportunity to respond to the draft of the report. Follow-up, if necessary, schedule up a follow-up audit. So we'll talk about security monitoring, goals and tools. The first goal of the security program is to detect abnormal behavior. When detected, the next step is to stop it. Overt acts are obvious and intentional. Covert acts are hidden and secret. Tools and techniques for security monitoring include baselines, which tells you what normal looks like. A report that states disk space is 80% full tells you nothing unless you know how much disk space is normally used. Alarms notify personnel of possible security incident. Closed circuit TV, systems that spot irregular behavior. Security monitoring for computer systems. Real-time monitoring provides information on what's happening as it happens. A network intrusion detection system is one example. Some examples include the host intrusion detection system, which is excellent for noticing activity in a computer as it is happening. System integrity monitoring, systems such as Tripwire enable you to watch computer systems for unauthorized changes. Non-real-time monitoring keeps historical records of activity. These include application logging. All applications that access or modify sensitive data should have logs that record who used or changed the data. And system logging, who accessed the system and what that person did. Activities you want to log include host-based activity, including changes to systems, access requests, and performance, and network devices, access, traffic type, and patterns. There are monitoring issues. The first one is called spatial distribution. Attacks are difficult to catch with logs if they come from a variety of sources across a wide area. And switch networks, harder to capture traffic on networks that are very segmented. Encryption, monitors can't see all the data to decide if it is suspicious. Encryption is carried out at various different levels. The data link layer encryption, wireless equivalency, equivalent privacy, WEP. Don't use WEP. It's outdated. Wi-Fi protected access, which is still somewhat outdated, and Wi-Fi protected access 2, which is what you should be using now. Network layer encryption, IPsec, some tunneling protocols, and application layer encryption, SSH, SSL, and others. Logging anomalies, false positives, a type 1 error, alerts that seem malicious yet are not real security events. False negatives, failure of the control to catch suspicious behavior, failure of alarm to detect a serious event known as a type 2 error. Log management. Store logs in a central location to protect them and keep them handy for thorough analysis. If a log file fills up, you are faced with three bad choices: stop logging, overwrite the oldest entries, or stop processing, which is a controlled or crash of your log system. Attackers sometimes purposely fill a log to cause one of these failures, so the storage device for your log files must be large enough to prevent this. To link activities between systems and logs, computers and devices on your network must have synchronized clocks. To prevent overwriting or modification, some systems write logs to a CD-ROM or some other write-only device. So that's the end of part 2. Part 3 will contain verifying security controls and monitoring and verifying security controls and testing.